ever wondered how powerful a nuclear bomb really is? Let's take a journey back to the mid-20th century, to the cities of Hiroshima and Nagasaki. In an instant, a single nuclear bomb reduced these bustling cities to ashes, claiming over 200,000 lives. But the horror didn't end there. In the wake of the bombings, survivors suffered from radiation sickness, their bodies ravaged by the invisible poison left behind by the blast. Even generations later, the legacy of the bomb lived on. Children were born with genetic mutations, their lives forever marked by the decisions of a world at war. The power of a nuclear bomb extends far beyond the initial blast, seeping into the fabric of society and changing the course of history. So we know that a nuclear bomb can cause massive destruction. But how does it work? A nuclear bomb, in essence, is a device that has the ability to release energy in an explosive manner as a result of nuclear chain reactions. Now let's break that down a bit further. At the heart of every nuclear bomb lies the science of nuclear fission or fusion. Fission bombs, also known as atomic bombs, work by splitting heavy atomic nuclei, typically uranium or plutonium, into two or more lighter nuclei. This splitting is forced by bombarding the heavy nucleus with a neutron, which adds to its instability until it can't hold together anymore. The result is a release of an incredible amount of energy and more neutrons, which then go on to split more nuclei, creating a chain reaction. On the other hand, fusion bombs, often referred to as hydrogen bombs, use the process of nuclear fusion. In this process, light atomic nuclei, usually isotopes of hydrogen, are forced together under extreme heat and pressure to form a heavier nucleus. This process also releases an astounding amount of energy, but requires the high temperatures and pressures only achievable with a fission bomb. In other words, a fusion bomb is essentially a fission bomb that triggers a fusion reaction. Now, let's get a sense of the energy we're talking about here. The energy released in a nuclear explosion is measured in kilotons or megatons of TNT. A kiloton is equivalent to the energy released by 1,000 tons of TNT, and a megaton is equivalent to 1 million tons. To put it in perspective, the bomb dropped on Hiroshima during World War II had an energy yield of approximately 15 kilotons, and it leveled the city. The science behind a nuclear bomb is fascinating, but it's also terrifying when we consider the potential destruction. The energy and the chain reactions involved in these devices are the same processes that power the sun, but when harnessed in this way, they have the potential to cause unimaginable devastation. The immediate impact of a nuclear bomb is just the beginning. The aftermath can be even more devastating. The chilling effects of a nuclear bomb don't end with the mushroom cloud. In fact, the immediate explosion is just the opening act. The fallout, the long-term effects of radiation on the human body and the environment, is the extended performance that can last for decades, even centuries. Radiation, an invisible yet deadly element of a nuclear explosion, can have a profound impact on the human body. Within weeks of exposure, acute symptoms can manifest, including nausea, vomiting, and a significant decrease in white blood cell count, leading to a compromised immune system. This is often referred to as acute radiation syndrome. But the assault on the human body doesn't stop there. Over time, radiation can lead to a higher risk of various forms of cancer, particularly thyroid, lung, and leukemia. It can also cause genetic mutations that can affect future generations. The children of survivors of the nuclear bombings in Japan during World War II have shown higher rates of intellectual disability and physical abnormalities. But the effects of a nuclear bomb aren't confined to the human body. The environment suffers too. A nuclear explosion can trigger what's known as a nuclear winter. This is a period of abnormal cold and darkness predicted to occur after widespread firestorms following a large-scale nuclear war. The smoke and soot arising from these fires, it's believed, would cool the global climate and lead to crop failure and famine. Radioactive fallout, the dust and debris that ascend into the atmosphere after an explosion, can contaminate vast areas, rendering them uninhabitable for years. In the case of the Chernobyl disaster, an area of approximately 1,000 square miles remains largely deserted over 3 decades later. In terms of scale, it's hard to comprehend the true magnitude of these effects. Millions of lives can be affected, entire cities can be decimated, and the genetic makeup of populations can be altered forever. The aftermath of a nuclear bomb is a chilling reminder of the destructive power of this weapon. Nuclear bombs are not just a thing of the past, they still pose a significant threat today. In the current global landscape, 9 countries collectively hold over 13,000 nuclear weapons. These nations are the United States, Russia, the United Kingdom, France, China, India, Pakistan, Israel, and North Korea. Each of these countries holds a piece of the puzzle that is the precarious balance of global nuclear power. The potential impact of a nuclear war is nothing short of catastrophic. It's not just about the immediate destruction, but also the long-term effects. The fallout would have lasting environmental impacts, and the global economy would likely collapse. The humanitarian crisis would be unparalleled in human history. It's a grim picture, and a stark reminder of the immense responsibility that comes with possessing such destructive power. The risk of nuclear war is a sobering reality that we must confront and work to prevent. The destructive power of nuclear weapons underscores the importance of nuclear disarmament. The sheer magnitude of devastation that a single nuclear bomb can cause is a stark reminder of why disarmament is not just an option, but an imperative. World leaders have recognized this, and over the years, there have been significant strides in international efforts to prevent nuclear proliferation. Take the Treaty on the Non-Proliferation of Nuclear Weapons, for instance. This international treaty, signed by nearly 200 countries, aims to prevent the spread of nuclear weapons and weapons technology, foster the peaceful use of nuclear energy, and further the goal of disarmament. It's a beacon of hope in a world that's seen the horrifying potential of nuclear warfare. But treaties alone aren't enough. It takes the collective will of nations, the relentless pursuit of diplomacy, and a commitment to peace. The only way to truly prevent the devastation caused by nuclear bombs is through global cooperation and disarmament.